All right, let's talk about a situation that, if you're an architect or a developer, you know all too well. You've launched your app, it's a hit, people are loving it, and then the messages start rolling in. The success you were hoping for is here, but it's brought a friend you didn't invite. Your app is suddenly painfully slow.
It's the classic question, right? The one that keeps us up at night. Everything worked perfectly in staging, it was fine on launch day, but now that the users are piling in, the whole thing is just grinding to a halt. So what's the deal? Well, you've just hit a performance wall, and funny enough, it's a direct result of your own success.
And this chart really tells the whole story. We call it the success penalty. As that user growth bar shoots for the moon, the application's speed bar can just tank. It's a classic scaling problem, you know? The setup that worked great for a few hundred users is now starting to crack under the weight of thousands. But hey, don't worry, this is totally a solvable problem.
To solve it, we gotta stop guessing and start investigating. So it's time to put on our performance detective hat and start looking for clues. Because every slow system, and I mean every single one, leaves a trail of evidence. Our job is just to follow it.
Now, our detective kit here on Google Cloud has two absolutely essential tools. First up, you've got cloud monitoring. This gives us that high-level crime scene view. Is the CPU totally maxed out? Is the disk I/O just screaming for help? Then, once we have a lead, we use cloud logging to zoom in and find the fingerprints. Things like slow query logs that tell us exactly which database operations are the culprits. So let's turn to our first suspect, which, let's be honest, is almost always the right place to start: the queries themselves. Before you even think about throwing more expensive hardware at the problem, you absolutely have to look at how your application is asking the database for data. So often, the biggest and easiest performance wins are hiding right here.
And just look at the difference an index makes. It's night and day. Without an index, the database has to do what's called a full table scan. Imagine reading an entire book, cover to cover, just to find one specific sentence. It's exhausting, but with an index, that's like using the book's index at the back. You just flip to the exact page you need, bam. A simple change like this can literally take a query from 10 seconds down to 10 milliseconds. Okay, so you've indexed your queries. They are absolutely lightning fast. You're feeling pretty good, but your app is still slow. What gives? Well, the problem might not be the speed of your queries anymore, but the sheer volume. You're just hammering the database with the same questions over and over again, and it's getting worn out. This is where we need to bring in a speed layer. The whole reason caching works so well really comes down to this classic idea, the 80-20 rule. In most apps, it turns out that about 80% of your requests are for the same 20% of your data. We call this hot data. Think of the most popular product page on your site, or a user's main profile info. Why on earth should we bother the main database for that every single time someone asks for it? So how does a cache, something like memory store, actually work? Well, think of a busy barista who keeps the most popular drink orders already made and sitting right there on the counter. When a customer comes in and asks for one, that's a cache hit. They get it instantly. Awesome. But if they ask for something unusual, that's a cache miss. The barista has to go make it from scratch. That's fetching from the database. But then, they're smart, they put a copy on the counter for the next person. This whole process just dramatically cuts down the workload on your main database. All right, we've optimized our queries, we've got a great caching layer, but for a truly massively successful app, sometimes even that's not going to be enough. You can eventually hit a point where a single database machine, no matter how beefy you make it, just becomes the bottleneck. It's time to think bigger. It's time to scale out. When you get to this point, you've basically got two main paths you can take. For apps that get a ton of reads, but not so many writes, think a blog or a news site, we use read replicas. It's like training a bunch of clones of your main database expert. They can handle all the common questions, which frees up the original expert to work on the new, important stuff, the writes. But for apps that are heavy on the writing, we turn to partitioning, or as it's often called, sharding. This is more like taking a gigantic filing cabinet and splitting it into lots of smaller, more manageable cabinets. Each one only has to deal with a small piece of the total load. Now, all these fixes are great for problems that are already happening, but the real goal, the pro move, is to shift from being a performance firefighter to a performance architect. And that means building a proactive strategy for performance right from day one. So what does a solid strategy actually look like? Well, it really boils down to 5 fundamental principles. This right here, this is your playbook. Number 1, index wisely. It is your cheapest, fastest first line of defense. 2, cache aggressively. Don't make your database do work it doesn't have to. 3. Scale your reads first with replicas. It's way simpler than sharding. 4. Only partition for writes when you see a write bottleneck, and you absolutely have to. And 5. The golden rule. Monitor everything. Your metrics are your map. Don't guess. Let the data tell you where the next problem is.
And that really brings us to the core philosophy of all this. Look, fixing problems when you're on fire is necessary, but proactive design, that's the mark of a truly great architect. It's all about anticipating growth and building systems that aren't just fast today, but are designed to stay fast tomorrow. So I'll leave you with this one question to think about for your own projects. Is your database built for the load you have right now, or for the success you're planning for? Thinking ahead like that is what separates a system that just survives from one that truly thrives. Thanks for tuning in.